Hello guys, this is Miss Amra. I'm back with my next lesson. So today we have 9-5. 9-5. Okay, so pretty much is the same concept. Before we had arithmetic series, now we have geometric series. So idea is you need to identify the series first, and based off that you need to pick that equation and plug everything in and find the sum. That's how we do it. So today we have geometric series. Geometric series. So first you should be able to check. I hope you remember, in order to be a geometric sequence or series, you have to have common ratio among any two or between any two numbers. So you need to identify if it's geometric or not. If it is, then this is the sum equation. So sum equation is sum, which is S, it's equal to A1 parentheses 1 minus R to power n over 1 minus r. All right. So basically what you need is you have to have first term. So you have to have A1, which is the first term. Then you have to have a ratio, R, which is the ratio, which we find by dividing second term by the first one. And the last thing you needed is n, which is number of terms. Number of terms. So if you have all three variables in this equation, so pretty much you just have to plug everything in and then evaluate the sum. But keep in mind, anytime any variable is missing, you could always go back to explicit rule and solve for that and then plug everything into some equation. So let me show you first example. So first example, I have 64, oh, it's plus, my bad. It's plus because it's a series, not sequence. 64, I have 16, 4, 1, 1/4 plus 1/16. It's a finite series. Why? Because we know where it's going to end. So it stops at the last term, so we know it's a finite series. Let me go back to my title. So I would say geometric series and finding sum of a finite series. So finding sum of a finite series. It's a finite series. Because for infinite, it's a different equation. All right. Anyways, so this is my series here. So I have to have my first term, which is already there. So let me pick a different color. So my first term is already there. So let's just label that A1. Then we have to have number of terms. So since it's finite series, so literally I'm just going to count. It's 1, 2, 3, 4, 5, 6. So n is 6. The only thing I have left is the ratio. And how do we find ratio? So basically, you just have to take second term, divide by first. Just to check, I'll do with next to as well. So 4 divided by 16, or you can do with next to if you want it. So the ratio is 16 divided by 64, it's 1/4. Now rest is pretty much putting everything into the equation. So sum of 6 numbers is equal to 64, which is the first term, 1 minus, I would put ratio in parentheses. Why? Because you know, in order of operation, you got to deal with parentheses first. So it would be 1/4 to the 6th power over 1 minus 1/4. Now rest is pretty much, you can put everything in your calculator, but make sure you simplify this part first. Or I don't know, if you want to type an entire equation in your calculator, you could do that too. So I did pretty much the whole thing. I did parentheses first. So after simplifying parentheses, I ended up getting 0.9975. So divided by 3/4. And if I simplify this whole thing, at the end, it would be 85.3125. Here you go. So that's my sum for this geometric series. Now let me show you one more example. I have another one. So let's say I have, oh, my bad. I have 3, my bad, there's something, why did this line here? Let me move this line all the way down here. There you go, that's better. Okay, so I have 3, let me erase this first. Let me just write it under. And I have, okay, so I have 3 plus 6 plus 12 plus 24 ... and plus 3072. This is what I have. Okay, first I need to check if it's a geometric or not. So 3 times 2, 6. 6 times 2, 12. 12 times 2, 24. Yes, it's a geometric series. So it means just because I just figured out the ratio, so I'm just going to write that first because we know later on either ways we have to have that ratio. So ratio is 2. Do we know first term? Yes, it is 3. Do we know number of terms? No, we do not. So anytime there's anything missing, this is where you need to go back to explicit rule. So explicit rule. Geometric sequence. What's the explicit rule? So it's an is equal to a1 times it by rn minus 1. If you need help on identifying or figuring out explicit rule, you can go watch the video we had before on this one. So just to get kind of better understanding on this, you could do that. But anyways, so an, I hope you remember it's the last term or the term you're solving for. So nth term would be my last term here, which is 3072. A1 is 3, ratio is 2, and it's n minus 1. Now we are solving for n in this equation. And how would you do that? So first, let's just isolate that expression. So I would isolate this expression. Oh, if you look closely, this is actually exponential equation because this n is an exponent, right? So technically it's exponential equation. And how do we solve exponential? I hope you remember. You need to switch exponential to log, and that's how we solve. Okay, first you need to isolate. So I would divide by 3. This becomes 1024. It's equal to 2 to n minus 1. So now this exponential is by itself. Switch it to log. And again, I hope you remember how to do that. So this is how we switch it to log. So you need to write down the log, bring down the base, which is 2, and swap. So this number would go this side. This one move to other side. So n minus 1 would be on this side. 10,000 or 1024. Now you need to put this log expression into your calculator. I hope you remember you would see log with 2 boxes, like there's a key with 2 boxes. You could use that, or you can just take log of the top divided by log of the base. So either ways you could do that. So if I put in my calculator, my answer is 10 for this number. It's n minus 1. Let's just solve for n, which is 11. All right, so I already have my n value. So now I gotta go back to my original equation. So let's find sum of 11 terms. A is 3, 1 minus a ratio is 2 to the 11th power over 1 minus 2. All right. Now, if you put everything in your calculator, don't forget you can even do this part first and then combine the rest. You could do that. If you put everything in your calculator, your answer would be 6,141. Here you go. And that's the sum of all of these numbers of this series. So this is pretty much all. So if you need help on anything, you can just pause the video. You can go back, or you can just comment on this, and then I'll try to answer that. Thank you guys. Thank you.